4.3 day 1, equations or writing equations of parallel lines. Does anyone know, just in general, of course you do. Does anyone know what a parallel line is? Yes, lines that don't touch, lines that don't intersect, right? They're gonna stay the same distance apart all the time. So today we're gonna be dealing with those kinds of lines. Oh, yeah, I guess probably. It probably would have been helpful. All right, so lines that do not intersect are called parallel lines. When you're looking at parallel lines, it's easy to see, like, based off a picture if they're parallel, but if you just have the equations, you need to know something special about the equations. Parallel lines are going to end up having the same slope, the same slope. Remember, your slope is the m, it's the number in front of your x. So if you look at these two equations here, y equals 2x minus 3 and y equals 2x plus 5, see how they both have a little 2 in the front? That means they're parallel. They have to have the same little number with the x. No, every morning I it's my allergies. Totally. All right, so what we are going to do is determine which lines, if any, are parallel. Now, with this, I give you guys a picture. I don't know if it showed up very clearly on the copy, so you can always write over it if you need to. Now, with this, with the picture, it's kind of easy to count out, so that's what we're going to do. We're going to count out our slopes here and double check that they're parallel because they need to be the same, right? So we're going to count out our rise over our run, and if we get the same numbers, we know that they're parallel. Do we remember how to count out our rise over our run? Yes, okay, perfect. So, you said no, but I know you're fibbing. Okay, so for your slope, remember slope is m. I'm going to color code this. We're going to count out our rise over our run. So if we're looking at this blue line here, if I want to count out this slope, remember, go from left to right. From this point, do I want to count up or down? The blue line here. The blue line. I'm color coding them for you guys. I want to count down 1. Okay, so my rise is -1. Then from there, should I count left or right? Right. 1, 2, 3, 4, 5. So that would be a +5. So this line has a slope of -1 over 5. So now let's check the red line. Okay, so the red line, we're on line B. Let's count that one out. From the left to the right, would I count up or down? Down how many? 1. So my rise would be -1 again. And then let's count to the left or to the right? To the right. 1, 2, 3, 4. Are those lines going to be parallel? No, but let's check the green one too. So this one was line A. I forgot to label these for you. This one was line B. All right, see the little B right here and the little A? That's where I'm getting that from. And then let's check line C. So for your slope, from the left, what do we count? Up or down? Down. Down 1. So that'd be -1. Yeah, and then over 1, 2, 3, 4, 5. Do you guys see any two slopes here that are the same? Yeah. Which ones? A and C. A and C, yeah. The first one is -1/5. That's A. Line C is a slope of -1/5. Those are the same. So would those two lines be parallel? Yeah. Yeah. So what we would say here, our answer, we would say line A and line C. Yeah, and you can write our parallel if you want. It's the only question it asks, so I'm just going to write those two things. I would like you guys to try out number 2. All right. Hayden, what did you get for your slope for line A? 2/3. Do we agree? Excellent. Asia, what did you get for line B? 2/3. Do we agree? That kind of rhymes. And then Brooklyn, what did you get for C? 3/5. Do we agree? All right. Are any of these lines parallel? A and B, they are both 2/3. So we are going to say that line A and B are parallel. Or if you just said like line A and B, that's totally fine too. So that's the only question it asks, right? Good. Are we okay with that? Yeah. Perfect. Okay, we're going to try this a few times, but with different information. So the first 2, you were given a picture, but this time we don't have a picture, we have points. Does anyone remember how you can find the slope if you don't have a picture, just coordinate points? Yep, we're going to use our slope formula. So let's write that down so we don't forget. Remember, your slope formula is m equals y2 minus y1 over x2 minus x1. If there's one thing you can do when you leave my class, it's going to be able to find slope because we do it so often. Okay, so that's what we're going to do. We're going to do this for each of these. So I guess I'll color code these so you can kind of see a little bit better. We'll do blue. Okay, so we're going to look at this first set of points first. So remember, subtract your x's with your x's and your y's with your y's, right? If you want, you can label it on there. So for line A, let's subtract our y's first. So if I want to subtract my y's, what would I put on the top of my fraction? Very good. 0 minus a -2 over, and then if I go 0 minus -2, Asia, what should I put on the bottom? Very good. 1 minus a -1. Lynn, what do I need to do with those double negatives? Very good. We need to make those positives. And then what's 0 plus 2? 2. And then what's 1 plus 1? 2. And can you reduce that? What's 2 divided by 2? 1. So your slope there is 1. All right, let's try out line B. So for that one, we got 4, 2, and 2, -2. 4, 2, and 2, -2. And you can always, if you want, you can always like rewrite the points down below when you do your work if it's all too smushed up there for you. Good. No, we've done so much slope. It shouldn't be too bad. Okay, so line B. So we're looking at 4, 2, and 2, -2. Someone help me out with the y's. How should we subtract the y's? Jake? Very good. -2 minus 2 on top. Annalise, what about for the x's? Yep, very good. 2 minus 4 on the bottom. All right, so -2 minus 2, and then 2 minus 4. What is -2 minus 2? -4. And then, yeah, oh, well, over what kind of a 2 if it's 2 minus 4? Negative, good. And then, guys, what's a negative divided by a negative? A positive. And then what's 4 divided by 2? 2. So this becomes a positive 2. Good. So far, do we have anything that's parallel? Not yet. Let's check the last one and see if we end up with anything. What color should I do now? How about green? It is green. It's just like a dirty green. Well, this is lime. This is lime. Oh, that's green. No, I disagree. It's all a shade of green. Anyway, can't believe we're arguing about colors. All right, line C. We have 0, 2, and -1, 1. Somebody help me with the Y's. Dallas. 1 minus 2. Somebody else, what about the X's? Aiden? -1 minus 0. Very good. What's 1 minus 2? -1. What's -1 minus 0? -1. What do I got to do with that since I have a negative on the top and the bottom? Right, make it a positive. And what's 1 divided by 1? 1. So this is just positive 1. Do we see any slopes that are the same? Yeah, lines A and C. So we are going to say that lines A and C are parallel. People at home, how are we doing so far? I haven't heard from anyone. Oh, good. I'm glad, Aaron. Always love Aaron's enthusiasm. No, he's at home today. Okay, let's try out number 4. Do we think we can try that one out by ourselves? I believe in you. Line A. Aiden, what did you do for the slope for line A? What'd you subtract? 9. What happened here? 9 minus 3, and then you did, yeah, because 1 minus the negative, right? So you switched that. Good, that should give you 6 over 2, which is 3 or 3 over 1. Very good. You can write it either way. Either way is fine. Line B. Okay. What do you, yes, if you had 6 over 2, that's right. You just didn't reduce it. Asia, what did you do for line B? Okay, 14 minus 12. That's what you did wrong. -1 minus a -2. You forgot the double negative. That's what happened. That's what happened. So that's why that'll switch, right? 14 minus 2 is 2. -1 plus 2 is simply 1. And you could leave that as 2 over 1 or change it to 2. Either way you like. That's probably just the little mistake you made, which is why it's important to show your work, right? You get most of the credit for that. Hannah, can you help me with line C? Yeah, 10 minus 8 on top. And then what about on the bottom? Very good. 6 minus 3. And then you'd get 2 over 3. And can you do anything with that? No. Hey, get off your phone. Addicted. All right. Are any of these the same? So are any of them parallel? No, none of these are parallel. So you could just say none. That would be fine. There's a sparkly one. All right. Questions on that? I don't know. I'll have to look. I don't know what this does. Oh, these? Oh. Well, that's fun. Yeah, use that. Okay. Anyway, number 5. Now these ones, again, little different. These ones are actual equations, right? So if they're actually equations, we just need to identify which number in the equation is our slope, decide if any of them are the same. So in line A, the slope here is 1/4, right? What about in line B? It's -1/4. And then what about in line C? It is also 1/4. I don't know why there's this 2 here. You don't cross out this little 2 on the front. I think that's just a typo. Yes, I do. Yeah, this one's just 1/4. So which ones are parallel? A and C. Here, I'll do it in this color for Lynn. Ooh. Oh wow, I don't like that because look, you can't read the line part. Cause it went that weird. If a student has to go here, wait, I'm gonna do the rainbow. That's so distracting. That kind of stresses me out. I don't like that.
No, don't erase it.
I'm not. I'm just gonna leave it. It stresses me out. I don't like that it's all different. Anyway, now let's look at line or number 6. Now number 6, what's different about this one? Right. These ones are not in slope intercept form, right? They are not in y equals mx plus b form, but can we fix them? We can absolutely fix them. I believe in us. So let's look at these. So we are going to fix these and write them in slope-intercept form. So for line A, I'll do that one down here. I'm going to recopy 3y minus 2x equals 6. Now we've done this, but it's been a second. This is when we use our 2-column method to reorganize our problem. Remember, you only want the y on the left, everything else needs to go. So if we're looking at this, put your 2 columns. Should 3y stay where it is or go to the other side? It's a y, so it's going to stay. What about the -2x? That one needs to go because it should be y equals mx plus b. Don't we want the x term on the other side? That's when you're trying to solve, not rearrange. This is a little different. So -2x needs to go over and become a +2x. And then what about the 6? It's good where it is. It's already on the opposite side. Now, do we want that 3 to stay next to that y? No, because it needs to just be y equals mx plus b. So does anyone remember what you need to do with the 3? You divide it. So we're going to divide everybody by 6. When we divide, we don't get to pick and choose. I'm sorry, by 3. I wrote the right number and said the wrong thing. Thank you. Thank you so much for forgiving me. You have to divide through by 3. When you divide, you don't get to pick and choose. Everybody gets divided. So, so what we're actually going to do when we write slope, won't that be the slope? And isn't it okay to have slope as a fraction? So do we need to do anything to 2/3? No, I would just leave it 2/3. 2/3x. Now, 6/3, can you reduce a 6/3? What would that become? 2. So that's your new equation for line A. Which number here is the slope? Yeah, the 2/3. The 2/3. Okay. Sorry. All right, now let's go up and I'm going to do this one over here. Let's do this for line B now. Line B will be a little bit easier. So for line B, maybe later, we have 3y equals 2x plus 18. Now, with this one, isn't the y already by itself on the left? There's nothing that needs to move over, but do we want that 3 next to it? Very good. We're going to divide by 3 again. Yep. Except pretend that looks like a 3 that does not even kind of look like a 3. I don't know what's my issue with 3s. I'm trying. All right. Listen. I gotta. All right. So y equals 2 over 3. Can you do anything with it? No. No, leave it. 2 over 3x plus 18 divided by 3. Yep, that is 6. So what's the slope of this one? 2 over 3. It's the same thing. Okay, so we've at least found one that's parallel. Now let's do the same thing with line C, and then we'll take a look at all of them and we'll be done with that. So line C, this one is 3y plus 4x equals 9. This one, do we need to do our two-column with? Yeah. Yeah, we got to move some things. 3y, should it stay or should it go? It should stay. 4x, yeah, go and become negative. What about the 9? Stay. Then divide through by what? 3. I heard nothing, Brooklyn, don't worry. Okay, so y equals negative 4 over 3. Can you do anything with that? Nope, just leave it. Negative 4 over 3x. And then what's 9 divided by 3? 3. What's the slope of that line? Negative 4 over 3. Is that one parallel? No. Which two are? A and B. They both have slopes of 2/3. That one's a little tricky. We don't do as many of those, but I like to at least look at one. So we are going to say that line A and line C, or I'm sorry, line B are parallel. Okay. At this point, let's take our 5-minute break, and at 9:02, we'll move on to the back. So people at home, 5-minute break, 9:02, we're going to move to the back. On the back. All right, so writing an equation of a parallel line. All last week, we learned about writing equations of lines. We're going to continue with that, except now specifically parallel lines. So we have 3 main steps here. So our 3 main steps, we are first going to find the slope of the parallel line. We got to identify it. We got to identify what the slope would be. Because remember, parallel lines have the same slope, exactly. So we got to figure out what slope we need to use. Then you're going to plug the slope and the point I give you into the point slope formula. We did that last Thursday and Friday. So remember, that's when you do y minus y1 equals m times x minus x1. Then you're going to rewrite the equation in slope-intercept form. That's when you're going to distribute, right, and add that one term over to turn it into a y equals mx plus b equation. I'll pause for a second. Okay, so if you look at these examples, it says write the equation of the line that passes through the given point and is parallel to the given line. Now, last week we did ones where I gave you a point and a slope, right? That's basically what this is. I'm giving you a point, and then I'm not directly giving you a slope, and aren't I giving you an equation that has a slope in it? And don't parallel lines have the same slope? So in reality, I'm giving you the slope. You just have to identify which number it is that you need to use. So are we done copying this now? Okay. So let's go look at number 1. We have a point here. So remember, your point is your x1 Yeah, x1, y1, and then your slope. Now, what's the slope of this line here? Y equals 2x plus 3. Yeah, 2 or 2 over 1, right? Okay. Now, we want to write the equation of a line that's parallel to this, which means our new line also has to have a slope of 2. So what that means is we have a point and a slope that we need to use. We want to use the same slope, so I'm going to use that same number. Now, if I have a point and a slope, can I go ahead and plug it into point slope? Yes, we absolutely can. So remember, point slope is y minus y1 equals m times x minus x1, where we're going to plug the slope in where we see the letter m, and we're going to plug our x1, y1 in where we see the x1 and the y1. Okay? And then we're going to simplify. So we have y minus y1. Which number is our y1? -4. So y minus a -4. Yes, we can go ahead and change that into a positive. Good. Equals m. What's our m? 2 times x minus x1, which is 5. Good. Who remembers what our next step is? Aiden? Okay, we're going to bring down the y plus 4, and then you said 2x minus 10. How'd you get that? Yeah, very good. We're going to distribute. So 2 times x is 2x. 2 times -5 is -10. So 2x minus 10. Is this sounding a little familiar, guys, from last week? Okay. Yeah, it's very similar, but just there's a slight change here. Or I guess it wasn't last week. I think it was Monday and Tuesday we did this. Yeah, it was Tuesday. I'm like getting all my days mixed up. Now, what's our final step? We don't want to divide. There's very good. Yeah, we got to get rid of this 4. It's being added, so to get rid of it, we are going to subtract it. So that's going to give us y equals 2x, and then you're going to combine this here. What's -10 minus 4? -14. Good. And then that is our answer. So with adding and subtracting, you can only add and subtract like terms. So you got to keep numbers with numbers. But when you multiply and divide, anything can be multiplied and divided, not just like terms. All right, let's take a look at number 2. Let's see which ones we're going to do together versus by yourselves. What do we have here? Okay, we'll see how many of these we do. We'll see what our time is like. But this is good practice because we didn't get to do a ton of these on Tuesday because we were a little short on time, and it's basically the same thing. So for number 2, here's our x1, here's our y1. What is our slope that we need to use? 1/4. Yeah, we're going to use the 1/4 here. So m equals, and you don't have to write it off to the side. I just like to so we know exactly what we're using. And then remember, we're going to use our y minus y1 equals m times x minus x1, where we're going to plug our 1/4 in for our slope, which is m, and we're going to plug our point in for x1 and y1. That's going to go where m is. Now, something I want to tell you guys here, because it just, sometimes people, I don't know, they have a little brain fart and it throws them off. See this +1 here? Guess what? It does nothing for you. It does not help you in any way. If you ever think that having this extra number here is going to confuse you, cross it out. It's not going to help you at all. Okay, just a heads up. Sometimes people will accidentally grab that number and use it in some way. You don't need it in this problem at all. It's almost like extra information, okay? You don't need it. All right, so let's go ahead and plug in what we know. We're going to have y minus y1, which is, y minus 2 equals m, which is 1/4, times x minus x1, which is -4. All right. Somebody at home, what would my next step be? Somebody at home, what would my next step be? Let's give him a chance. Aaron, what do you think I would do now?
Come on, Aaron.
Well, what do you think I could do with this double negative, Aaron? Okay, yeah, that's definitely something we could do. Anyone else at home, something that we could do now? Mason, do you have any ideas? What could I maybe do with the 1/4? Yeah, we can distribute it. Yeah, good. We're going to distribute the 1/4. So on the left, we're going to drop down our y minus 2 equals, and then we're going to distribute our 1/4. What is 1/4 times 4? What is 1/4 times x? My bad. 1/4 x. And then now 1/4 times 4. Remember, isn't that just like doing 4 divided by 4? Yes, that's just 1. Good. And then last step, we don't want to subtract it, we want to add it, right? We want to add the 2 because we want to move it. It's a negative right now, so to get rid of it, we are going to add it to both sides. Good. So we have then y equals 1/4 x plus 3. Good. 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 Hayden, just put your phone in your backpack. It's like if it's there, you can't help yourself, right? All right. Let's do number 3 together, and then I'm gonna have you guys practice number 4, okay? So let's look at number 3. We got 18 and 2. That's our x1 and our y1. Corey, you awake over there? So what we're technically doing right now is writing the equation of a line that is parallel to the one I'm giving you. No, it's not actually, but, well, there you go. So now for this one, what is our slope of this line that I give you, Annalise? 1/3. And we're writing the equation of a parallel line, so we want to use that same slope. So we are going to use that m equals 1/3. And then we're going to plug into y minus y1 equals m times x minus x1. All right, I'm going to go through and call on people for plugging things in. So we're going to do y minus, Kaysen, what's our y1 value? Y minus what? Kaysen, what do you think? Jesse Campbell, y minus what? What's my y1 value? Nick Lopez, what's my y1 value? I don't know if they're there or not. Okay, so let's go around. Brooklyn, what's my y1 value? 2 equals m. Corey, what's my m that I'm going to use? I'm sorry? We're the slope, yeah, 1/3. The 12 here, you can actually cross it out. You don't need the 12. So we're going to plug in 1/3 and then x minus, Hayden, what's my x1? 18. Good. All right, Jaden, what's my next step going to be? Yeah, we are going to distribute. Yep. 1/3 x. And then how'd you get 6? Yeah, it's basically the other way around. But yeah, if you're taking 18 times 1/3, that's the same thing as 18 divided by 3, which is 6. So minus 6. Olivia, what would be my next step? What needs to move over? Yeah, very good. We are going to add 2 to both sides. Good. So then you're going to have y equals 1/3 x, and then negative 6 plus 2. No, negative 6 plus 2 is negative 4. Remember, check in your calculator if you need to. Jaden, you say goofy numbers all the time. All right, I want you guys to try out number 4. All right, number 4. Here's your x1, your y1, and then your slope is negative 5. Jaden, help me with the left side of my equation. What should I write on the left side? Yeah, y minus 2 equals, then Dallas, what should I put now? We're on 4. Jaden. Jaden, be nice. Negative 5, okay, times, and then Aiden, what do I put in my parentheses? X minus, you're looking at the last part. What do we plug in for y1? We're over here. Oh yeah, for y1 is 1. Yep. So that's okay. So guys, do we need this 4 that's up here? No, remember you can cross that out if you want. And now, Jake Sanders, help me, what do I do now? Okay, so negative 5x, and then what's negative 5 times negative 1? Positive 5, good. Yep, we're gonna then add the 2. Add the 2, and you should get y equals negative 5x plus 7. How do we feel about that, guys? Right. I don't know. Do you guys do we feel like we need one more, or one more? Okay. If we can do one more, that's okay. Hey, you're not the only person in here, bud. Let me tell you. Don't worry about it. All right, number 5. I actually do want to look at 5 because it has a negative slope and a fraction, and then and then we'll spend some time on our homework, okay? So number 5. I did, but you guys still get confused by negatives. All right, so you got x1, y1, and then your slope is what? Negative 1/5. Good. So now we're going to do y minus y1 equals m times x minus x1. Yeah, well, y minus a negative 3 equals m. Bailey, what should I plug in for m for my slope? No, I just haven't called on you yet today. That's actually what it was. Okay, well, that's okay. It's written right here. What are we plugging in for m? Jaden, hush. Yeah. Yeah, what number should I plug in here? We're going to plug in negative 1/5 for m. And then x minus x1. Annalise, what should I plug in for x1? 10. Good. All right. And then I heard someone say turn my double negative into a positive. I agree. And then drop down your y plus 3 equals. And Lynn, now what should I do? Yep. Negative 1/5 times x will give me what, ladies and gentlemen? No, the times the x part, not the other part. Negative 1/5 x. And now when you multiply by 10, now be careful. What's a negative times a negative? A positive. And then you said 50, you were thinking 5 times 10. But remember, this is a fraction. So if you had 10 over 5, what's 10 over 5? 2. So plus 2. Or 10 divided by 5, same thing. Good. And then, Hayden, what would be my last step? We are going to subtract the 3. Good. Minus 3. And then you'll get y equals negative 1/5 x minus 1. Good. How are we feeling about this? Pretty good? Good. Good. Okay. So we have 10 minutes. So guys, listen please, I'm talking.